All right, you guys, we're going to go ahead and look at what we do when we're determining trend or no trend. And after we've determined that, what do we do moving forward to get some estimated values? So let's say we have this top table here. So we have the shape of a projectile is subangular and the angle of release is 45 degrees. That's telling us our control variable. Our independent variable is going to be our mass in grams right over here. And our dependent variable is our distance traveled. So we calculated our averages and our uncertainties already. Whenever we're doing trend or no trend, we are comparing the range and the uncertainty. So let's go ahead and try to find that. So our range, we remember, is we look at our averages, we take our largest of our average value, and subtract our smallest. So max average minus min average. Our maximum here looks to be 2.15. Our minimum looks to be 1.65. So 2.15 minus 1.65 is 0.5. And this is a distance, so that's going to be in meters. When we look at our uncertainty, we're just looking at the largest uncertainty for the entire experiment, which is going to be our plus or minus 0.1. Now we're going to go ahead and compare these two values. This is also plus or minus 0.1 meters. And I see that 0.5 is greater than 0.1. So that tells me that my range is greater than my uncertainty. This suggests that I do have a trend. And since I have a trend, I'm going to use graphical analysis and create a math model. Once you create that math model, you can go ahead and you can plug in different values. Okay, let's try another one. So here, this is actually from our designing experiments video. Had to play with the numbers a little bit, but what we see here is if we look at our range when we take our maximum value, that's our 16.7, minus our minimum average value, our 15.7, we get a range of 1 centimeter. Well, if we look at our uncertainty, our largest uncertainty in the entire table is going to be plus or minus 2.2 centimeters. So in this case, our uncertainty is greater than our range, or our range is less than our uncertainty. And so what that tells me is there's no trend in our data. However that mass of the ball is changing, it doesn't necessarily change that maximum height. So if I ask you to predict a value for the maximum height of a ball that is 7 grams, we're not going to be able to write a math model to predict this. So instead of doing that, what we're going to do is we're going to go ahead and find the best average value of this table. We know that that average maximum height is going to be somewhere around all of these numbers here. So we're just going to take the total average. Now, 2 ways you could do it. You could add up all of these numbers right here and divide them by 15 because we have 5 sets of 3. Or if you wanted to make it a little bit easier on yourself, you could actually just take the average of the averages. So that's what I'm going to go ahead and do. Average of averages. So I'll do my 16.3 plus 16.1 plus 15.7. 16.7 plus 15.9. There are 1, 2, 3, 4, 5 numbers here, so I'll divide by 5. Go ahead, put that in my calculator. if you want to practice this with me. And I end up getting an average of about 16.14 centimeters. Okay? When I'm reporting this value, I do want to make sure that I'm also including that plus or minus 2.2 centimeter uncertainty. But really, when we have no trend, we're going to take the average of the averages, or the total average of our table. All right, thanks for watching, you guys. If you have any questions, write them down, bring them, ask your teacher. Otherwise, have a great rest of your day.